Alright, in this video we are going to explore some applications, sort of real world-ish problems, like word problems sometimes people call them, that involve polynomials and especially multiplying polynomials. But we're going to start with number 5 right here. Guys, this problem is going to blow your mind. You're going to be like, what? So check it out. I'm gonna have to make it really tiny though. I didn't really leave enough space for you, and when I say I mean whoever made this worksheet. Miss Baker! Alright, sorry about that, I got something in my throat. Let's see. Anna knows that the perimeter of her backyard is 6x squared plus 14x feet. Perimeter. Okay, do you guys know what perimeter means? Of course you do. Look at this blue rectangle. If I told you that the height of this rectangle was, let's say, 4, and the base of this rectangle was 6. If I then asked you for the perimeter, you would be able to tell me, because you understand that the perimeter is the sum of all the sides. So if you add up these two right here, okay, that's 10 so far. These two over here, that's another 10. So that's a total of 20. So that would be the perimeter, it would be 20. Okay? I know that you know that. If I throw some variables in here, let's see, I was calling this the base. So if this is the base and this is the height, then we've got two bases, you know, in terms of the perimeter, and I've got two heights. So the perimeter would be like having you know, base plus height plus height. These are like terms, so I could say that the perimeter is 2 times the base plus 2 times the height. Okay, so that's just a little something about perimeter to keep in mind. Now, they told us that the perimeter is this right here, 6x squared plus 14x. Okay, so whatever else turns out to be true about the perimeter, we can know for a fact that the perimeter is, I already forgot it, Alzheimer's, 6x squared plus 14x. 6x squared plus 14x. Okay, we can know for a fact that that will be the perimeter. Now, if the length of her backyard is this, then what is the width of her backyard? Okay, the length of her backyard is right here. So they're saying that like if this is the length, so this is 2x squared plus, you know, I need to zoom in even more. Okay, so they told us that the perimeter is 6x squared plus 14x, and they told us that the length of the rectangle was, well, the backyard, was 2x squared plus 3x minus 7. Alright, and we are supposed to find the width, okay, which for now let's just call it W. So our goal is to find out what W is. Well, if the length is 2x squared plus 3x minus 7, then that's going to be true on both sides of this rectangle. So let's label it up here too. So that's 2x squared plus 3x minus 7. Okay, and if the width is W, then that's going to also be true on both sides. Okay, so let's form an expression for the perimeter. We know the perimeter has got to equal this, but the perimeter is also the sum of all of these sides. Okay, so the perimeter, let's take these two lengths first and add them up. Okay, so because the perimeter should be the sum of all four sides, so that means if we take 2x squared plus 3x minus 7, okay, that's this up here, and we add on 2x squared plus 3x minus 7. Okay, that's this down here. And then eventually I'm going to add on the two w's as well. So, eventually I'm going to say plus, w plus w. Or I could just say plus 2w, couldn't I? Plus 2w. Okay, then that includes all of these. So if I take this and add it all up, that should be the perimeter. Agreed? Okay, because that's the top, the bottom, and the two sides would be the 2w. Okay, so let's add all this up. But right now, I'm going to add these two up. And then I'll just stick the 2w on the end of it. Because these are all like terms, right? So 2x squared plus 2x squared, that's 4x squared. 3x plus 3x, that's 6x. Negative 7 plus negative 7, that's negative 14. Alright, now I'm going to add in the 2w. So plus 2w. So this is an expression for the perimeter. Alright, 4x squared plus 6x minus 14 plus 2w. That's the sum of all four sides. Okay, so this is the perimeter. Alright, I'm just going to label this temporarily. This is the perimeter. Okay, but we know that the perimeter is supposed to equal 6x squared plus 14x. So that means all this perimeter right here better equal 6x squared plus 14x. Okay, so there's the perimeter that they gave us, and then there's the perimeter that we found by adding all these up. Those two perimeters better be the same thing. So remember, we're supposed to find the width, w. So what I need to do is solve this equation for w. I'm going to get w by itself, and that should be the answer. So let's work on that. Let's see. So let's try to move everything to the other side, if you will. So I'm going to subtract 4x squared from both sides. Okay, I told you this problem was going to blow your mind. So those are gone. So right now I've got 6x minus 14 plus 2w. Alright, 6x squared minus 4x squared, that's 2x squared plus 14x. We're supposed to find the width, so I'm looking for the w. So I'm going to get rid of the rest of this as well. So I'm going to subtract 6x from both sides like so. Okay, I'm running out of space. That's great. So these are gone now. So now I've got negative 14 plus 2w equals 2x squared. Let's see. So that's going to be 8x. Alright, and get w itself. So to get rid of the negative 14, I'm going to actually add 14 to both sides, so they cancel out. So I'm going to do a plus 14 plus 14. So these are gone. Alright, so now I have 2w equals 2x squared plus 8x plus 14. Alright, last step. If I want to get w by itself, I need to get rid of the 2. So I'm going to divide everything by 2 like this. Divide by 2, divide by 2, divide by 2, divide by 2. Okay, so these 2's are going to cancel out. I guess I'll put my final answer over here off to the side. So that's going to leave me w equals, these 2's cancel out as well, so that leaves x squared. 8 divided by 2 is 4, so that'll be plus 4x. Okay, and 14 divided by 2 is 7, so plus 7. Alright, so the width is x squared plus 4x plus 7. Yay! Alright, did I just blow your mind? Well, I did warn you. Alright, you might need to watch that video again. There's a lot of steps, a lot of moving parts. Easy to get lost, like a babe in the woods. Okay, let me zoom out so we can see number 6 better. Alright, this is another mind-blowing problem. The area of the square below, okay, this shaded thing, is represented by the expression 4x squared plus 4x plus 1. The area of the rectangle, the little white thing, is represented by the expression x squared minus 5x plus 6. Using the diagram below, find the area of the shaded region. Okay, so the first thing is you have to wrap your mind around this picture right here. We got a square, a rectangle, and then we have this shaded area. So sometimes it's hard to see what they're even talking about. So I'm going to sort of split this apart so it's easier to see. Okay, I sort of redrew this picture so I can show you how it breaks apart. Okay, so when you see this image here on the left, there are really two things being put together. Okay, and because I recreated it, I can kind of separate it out. So what we have is we have a square and a rectangle. Okay, so that's sort of two separate things. So what I want you to see when you look at the picture on the left, I want you to picture this as a shape with a hole in it. So you could picture this as being made out of cardboard or something, and this is a hole in it. Like, imagine you could just put your hand through that. Okay, so the relationship between the square and the rectangle and the cardboard with a hole in it is that if you took the square, so imagine we have the solid piece of cardboard, you would have to cut a hole in it with the rectangle to make it be just the border. Okay, so in other words, you could say that if you take the whole square and you subtract the rectangle, then that will leave you just the border. Okay, in fact, maybe I'll move this over here. Let me rearrange my equation a little bit. Okay, so the whole square minus a rectangle, okay, like poof, I'm cutting out the rectangle, will leave the border. So in fact, let me just put that into words over the top here. So we could say the square, oh, that's too thin. We could say the square minus the rectangle equals the border. Whoa, did I really not put an E on square? Yeah, the square minus the rectangle equals just the border. Okay, does that make sense? If I take the whole square and I sort of cut out the rectangle and take it away, then that's going to leave the border. All right, so what can I do with that? All right, so if you understand square minus rectangle equals border, then we can just put in our expressions. Okay, let's see. The area of the square is represented by this expression. So this is the square. Okay, so we're saying square minus rectangle. So we have, what's that? 4x squared plus 4x plus 1. So I'm going to put that down here. Okay, so the square was 4x squared plus 4x plus 1. I guess this is the rectangle. Let me just scan across it. The area of the rectangle is represented by the expression x squared minus 5x plus 6. Okay, so the rectangle is x squared minus 5x plus 6. So if you understand that the square, if you take away the rectangle, is going to give you the border, then using the expressions that they gave us, that means 4x squared plus 4x plus 1, that's the square, minus the rectangle, okay, minus x squared minus 5x plus 6 should equal the border. Okay, so this expression on the left should equal the border. The square minus the rectangle will give us the border. And the border is what we're supposed to find. Okay, we're supposed to find the area of the shaded region, okay, which is the border here, just the outer part. Okay, so all we really have to do is simplify this subtraction, and that's going to be the answer. So the rest is easy. The hard part was understanding this equation. If you understand the equation, the square minus rectangle equals border, the rest is actually pretty easy. So here we go. Treat this subtraction like it's a -1, like we've done many times before. And then we take that -1 and we do the distributive property with it. Okay, so over here that's going to give us -x squared plus 5x minus 6. Alright, this is just going to come down unchanged. So I'm still going to have 4x squared plus 4x plus 1. And that should all equal the border. Alright, the rest is just a matter of combining like terms, right? So I've got my 4x squared and my minus 1x squared. So that should be 3x squared. Okay, next I have my 4x and my 5x. Put those together and that's 9x. Last, I've got -1 and I've got, I'm sorry, I said -1. I've got +1 and I've got -6. Put that together, that's -5. Okay, and that should equal the border, which is what we were trying to find. So this is the final answer, 3x squared plus 9x minus 5. Okay, so that was a little mind-blowing. Alright, well that was 2 mind-blowing problems in a row. Let's see what number 7 has in store for us. Not mind-blowing at all. So this should be quite simple. Find the perimeter and the area. Okay, so very straightforward. Alright, this is DOK1, as we say in the biz, depth of knowledge, level 1. Okay, let's start with the perimeter, only because they mentioned that first. We know that the perimeter will be the sum of all 4 sides. Okay, so let's label them all. We have 3x squared plus 6x minus 10 is the length. So that's going to be the same down here, 3x squared plus 6x minus 10. And you know, the width, or some people would say the height, is 3x plus 5. Well, again, that should be the same on both sides. So the perimeter is the sum of all 4 sides. Top plus bottom plus left plus right, all 4 sides added up. So let's just add up all 4 sides. So if I want the perimeter, let me just label what I'm doing, perimeter. The perimeter is going to be the sum of all these, so I'm going to write, I feel like changing colors. Let's do purple. The perimeter is going to be 3x squared plus 6x minus 10. Okay, that's the top. And then I'm going to do another 3x squared plus 6x minus 10. That's the bottom. Then I'm going to do a 3x plus 5. So there's 3x plus 5. That's the left. And here's another 3x plus 5. That's the right. So if I add up all of this, that should be the perimeter. Okay? So, negative 10 and negative 10. So far that's negative 20. Okay? And in fact, this is what I'm thinking in my mind. These two together make negative 20. These two together make positive 10. Okay? So, negative 20 and positive 10, that's a total of negative 10. Okay, so I've got negative 10 right there. Or you could look at it and say, these two 5s make 10, positive 10, that's going to cancel out this negative 10 and leave the other negative 10. Whatever makes you happy. Okay, now look at the x's. I've got 6x plus 6x, that's 12. Alright, plus another 3, that's 15. Plus another 3, that's 18. So I've got 18 x's. Okay, so plus 18x. And then I've just got 6x squared. 3 and 3 makes 6. So 6x squared. So there you go. I added up all four sides, and that's the perimeter. So that was 6x squared plus 18x minus 10. Okay, now the area. The area is the length times width. Okay, the base times height. So I think I'll do that in red. No, I'm tired of red. Green. Haven't used green in a while. Okay, so let's do the area. So the area is going to be, alright, I want to multiply these two together, okay, because it's like length times width. But I like to put the binomial before the trinomial. It just makes me feel better. So I'm going to put 3x plus 5 first, and then 3x squared plus 6x minus 10. So 3x squared plus 6x. I'm off camera. No! You can't see what I'm doing anymore. But that's okay. I'll just scroll over now. Okay, so I'm doing the length times the width. Of course, the order shouldn't matter. And that should be the area. Alright, how to do this? We're going to need a double distributive property. Time out, guys. My mom's calling. That's my mom's ringtone. Oh no, I accidentally hung up on her. Oops, better fix this. I'm back. My mom is always driving long distances to see her friends and such. I worry. Anyway, double distributive property, I believe I was saying. So we have to take this 3x. So ignore the 5. Pretend like the 5's not there for now. We're going to take this 3x and multiply it by all three of these things. Okay, so 3x times 3x squared, that's going to give us 9x to the third power. Okay, 3x times 6x, 3 times 6 is 18, and then x times x is x squared, so 18x squared. And then 3x times negative 10 is negative 30x. Alright, now we're going to switch gears. Ignore the 3x now and pay attention to the 5, because we're going to take that 5 and do the distributive property with it. Okay, so 5 times 3x squared is 15x squared. Okay, so I'll have 15x squared right here. Line up your like terms. It'll make your life easier. 5 times 6x, well, 5 times 6 is 30, so that'll be 30x plus 30x. And then 5 times 9 is 50. Okay, if we add all that up, that should be the answer. Okay, so we'll bring down our 9x to the third power. And then let's see, so that's 33. x squared. If you add those up, the positive 30x and the negative 30x cancel each other out. Okay, so that's just gone. And then we've got the minus 50. Okay, so that should be your final answer for the area. Alright, so I'm just going to cut and paste that over here because they want it on the line. Alright, so there you go. There's your perimeter, and there's your area. Alright, this video is getting kind of long. How many more of these we have? I have 8 and 9. Alright, I guess I won't make a whole nother video. Alright, sorry this video is a little bit long, but what are you going to do? These are mind-blowing problems. Now, find the perimeter of the object below. Okay, that's not so mind-blowing. So the perimeter is just the sum of all the borders on the outside. You'll notice that these marks right here mean these two sides are congruent. So they should be the same length. So if that side is 6x minus 4, then this side is 6x minus 4. Same thing here. That's a rectangle. So if this is 12x plus 3, then this over here is, I can barely fit it, 12x plus 3. So the perimeter will be the sum of these 5 things. Okay, I like to stack these things up, people. So the perimeter, okay, will be the sum of all 5 of these sides. So I've got on the bottom here, I've got my 14x plus 13. Alright, then on the sides, I've got 12x plus 3 and another 12x plus 3. Okay, it's for the left and the right. I don't like that 3 though. Alright, and then for the roof, I've got 6x minus 4 and another 6x minus 4. Okay, so for the perimeter, I'm going to add all this up. Okay, and that should be the perimeter. Alright, so I've got 13. 13 plus 3 is 16. Add another 3, that's 19. Okay, 19 minus 4, that's 15. And then minus another 4, that's 11. So I'm going to have plus 11. Okay, alright, if you had any problem with that, I say use a calculator. Alright, so I've got 13 plus 3 plus 3 minus 4 minus 4. Okay, so there's your 11. So feel free to use your calculator. In fact, I think I'll just go ahead and do that for my x's. So I've got 14 plus 12 plus 12 plus 6 plus 6. So 14 plus 12 plus 12. Okay, plus 6 plus 6. 50. Okay, or 50, as they say in the hood, but I guess I shouldn't say that because I'm a teacher. You know, got to keep it educational. So 50x plus 11, that's the perimeter. Okay, that wasn't so bad. Let's move on to number 9. Maybe this will be equally as easy. Write an expression for the volume of the gift box. Okay, this is another easy one. Love it. You need to understand that the volume is going to be the length times the width times the height. Alright, just multiply all 3 dimensions and that's the volume. So in this case, the volume, alright, the volume should equal the product of all 3 of these things. So I've got 2x times x plus 4 times x minus 3. Okay, multiply all these together and that should be your volume. It doesn't really matter whether you do these two first and then multiply that by this, or if you do the two binomials first and then multiply by the monomial. Either way, you're going to get the same answer. Right now, I think I feel like doing these two first, and then I'll distribute the monomial at the end. So that's what I'm going to do. Okay, so double distributive property. If I take this x and I multiply it, I distribute. So focus on this. I'm going to take this x and I'm going to go like this. So x times x is x squared. X times negative 3, well, that's negative 3x. Then I'm going to switch it up. Let's see, I'll go green. Now look at the 4. I'm going to take the 4 and distribute like that. So 4 times x will be plus 4x. 4 times negative 3, that's negative 12. Okay. Meanwhile, I've got this 2x out front. It hasn't gone anywhere. Okay. So I'm going to combine these like terms right here. So I've got my 2x, but then the result of multiplying these two binomials together will be x squared plus x minus 12. So I've got that. So now I need to do the distributive property. Okay, nah. Alright, so I'm just going to take my 2x and do the distributive property like that. So 2x times x squared, that will be 2x to the third power. 2x times x is going to be 2x squared. And 2x times negative 12 is going to be negative 24x. So this would be an expression for the volume. Okay, I think that was the last problem. Let me just zoom out and get a bird's eye view of the situation. We did them all, you guys. Okay, this is a long video. 33 minutes. Alright guys, I really hope this was helpful. There was these first two problems, especially number 5 and number 6, those were tough. So I hope I helped you to understand it. Feel free to come in the morning. You know, if you need extra help on these, unless this is on YouTube and you're watching this from Thailand or something, then it probably wouldn't be worth the flight. In that case, I will see you on the next video.